Welcome to another video. In this video, we want to look at sequences and series, and we're going to look at the arithmetic series. So we previously learned how to prove these two formulae, and now we're going to use all of them to answer questions. So now I just want to first clarify what a series is. So we had a pattern that goes 7, 10, 13, right? This was our arithmetic pattern or sequence. But then now, if it's a series, all these terms will be adding each other. And we usually refer them to the sum of. Because remember, when things are adding each other in mathematics, we just say sum of. So this could be, if I have 3 terms, I could say the sum of the first 3 terms. And it could be the 7 plus the 10 plus the 13, and we would get our answer there. Or you can have the sum of the first 50. Now, when you have 50 terms, it will be super hard for you to try and add all 50 terms individually. So that's why we have a formula that will help us to work out the sum of the first 50 terms, which is that one over there at the top. So this one there at the bottom, we use it only if you know what the last term's value is. All right, so let's continue here with these questions, and you will pretty soon understand everything. So the solution to the first question, how many terms are in the series? We have to use the general form, the standard form here, to work out how many terms are in the series, because we are given the last term, which is 64 over there. So we are given the last term, but we don't know what term number this is. This is term number 1, 2, 3, but we don't know what term number this is, but we do know its value. So the term number, remember, it's going to be the n value of this. So I'm looking for the n value, and this formula is the formula that will help me to work out the n value. Because I do know what Tn is going to be, it will be 64. You can't use the other ones because you don't know the sum of. It's the sum of. Okay, you don't know the sum of. We know the term's value. So we have 64, and the a value will be 7 plus the n is what we are looking for, and the d will be 3. It's very easy. 10 minus 7 is 3. 13 minus 10 is 3. All right, so we put this in our calculator, and we will get 20. Okay, now we go over to the next question. What is the sum of? When they say sum of, they're looking for the Sn. What is the sum of all the terms in the series? So we can use Sn is equals to n over 2 a plus l. We're going to use this one. Why? Because we do know the last term. But you can also use the top one, which is also preferred. That you can use whenever, even if you don't have the last term. All right, so what we are going to do here, we'll say S of 20, the sum of the first 20 terms. Where there's an n, you have to put 20 over 2. The a value is 7 plus l. The l is going to be 64. Then when we put this in the calculator, we're going to get 710. All right, so let's keep it going, guys. In the next question over here, they say the sum of n terms of an arithmetic series is Sn of the. So this is a formula that will help us to work out the sum of the whatever terms. So the first question, solution. So the first question, they ask us to work out how many terms, which is n, how many terms of the series must be added so that the sum of is 425. So Sn is 425. So obviously, we are now going to use Sn is equals to n over 2, 2a plus bracket n minus 1d. We're going to use this formula. We don't know the last term's value, so you can't use L, the one with the L. So we know Sn. They say, well, it should be 425. But the n is something we don't know, right? We're going to try and work that out. And then we know the a value is 7 plus the n is something we don't know, right? We have to subtract 1 and so over here, the d value, we know the d value is going to be, let me see. All right, so I'm thinking my own things. I'm so sorry about that. We have to use the formula that is given there because they have gave us the formula that we need. So we can't use the general one. We have to use the specific one that they have given us over here. All right, so let me just catch up to you guys because I know you were screaming, no, don't you use this one? All right, so let me put this in. We have 7n plus 15. All right, so this is what we're going to have. The Sn is 425, but we have to use the formula that they have given us over there. All right, so now we have to work out n, and we're going to just take the 2 to the side. It's going to multiply to give us 850 is equals to 7n squared plus 15n. Because when the 2 is gone, the n is going to multiply inside. Now we're going to put a standard form of 7n squared plus 15n minus 850. When we factorize this, or you can use a quadratic formula because it is a quadratic equation. So you solve it by factorizing. If you can't factorize, use the quadratic formula. So I'm going to factorize it. It's going to be n minus 10. And then it's going to be 7n plus 85. That's what we're going to get. So that means that n could be 10 or n could be negative 85 over 7, which is not applicable over here. So our final answer will be n equals to 10. So you must add the first 10 numbers so that the sum of, which is Sn, can be equivalent to 425. That's what we have concluded here with our sum. So just make sure you do know how to factorize a trinomial, guys. Very important. Let's continue to B. So over here, let me write down again solution. Let's say determine the sixth term of the series. So I want to explain something, guys, and it's the formula we have here at the corner. If I'm looking for term 6, I'm going to take the sum of the first 6 terms and subtract them with the sum of the first 5. If I'm looking for term 10, I'll take the sum of the first 10 terms minus the sum of the first 9. If I'm looking for term 13, I will take the sum of the first 13 minus the sum of the first 12. That's the meaning of the formula we have there at the corner. So I hope you understand, but I'm going to explain it a little bit more. Let's say I have a simple series that goes 2, 4, 6, right? And I want to know, this is our third term, by the way. So this is term 1, term 2, term 3. So I want to know what is the third term. Let's say I didn't know. So I want to show you that the third term can be found by taking the sum of the first 3 terms minus the sum of the first 2 terms. And the first 3 terms, it's 2 plus 4 plus 6. You can clearly see them. So you must add all of them. Minus the sum of the first 2 will be 2 plus 4. So when we do this, we get 12 here minus 6 there. 12 minus 6 is 6. So we know that the third term is 6. So this formula does work. Okay. So just make sure you understand this formula because we're going to use that now. All right. So I don't need to erase that. Let's continue here. So the sum of the first 6, I'm going to use the formula they gave us at the top. I'm going to have 6 over 2, where there's an n, you must put a 6. 7 times 6 plus 15. That's what we have. And then 5 over 2, 7 times 5 plus 15. That's what we have for the sum of the 5. So this is a S and a 5. Okay. So let's put this into the calculator. And let's see what we actually going to be having. So I'll put 3 times, 42 plus 15 subtracted by 5 over 2 multiply by 85 plus 15. And our answer would be 46. So that's the sum of, that's going to be term 6. So term 6 has a value of 46. Let's move over to the next question. This question asking us that the third term of an arithmetic sequence is this. and the seventh term is given as that. They're asking us to determine the sum of the first 51 terms of the sequence. Now I want to start my sum day. So let's have a solution here. All right, so I'm gonna start today. I'll use Sn because I don't know the last term. So I need to use Sn is equals to n over 2, 2a plus n minus 1d. And then I substitute. I want the sum of the first 51 terms. So I say 51 over 2, but I don't know what the first term's value is. So I'm going to leave it now. And then I say the sum of the first 51, I put 51 minus 1, and I don't know what the d value is as well. So the problem here, what's hindering me, is the a value and the d value. So I need to work those out. And we already had learned a skill to use this information and that information to solve simultaneously for a and d. They're giving us that term 3, t3, the third term, is equal to minus 7. But we know how we can rewrite term 3. It's going to be a plus 2d. We have learned this is equals to minus 7. And then they're also giving us that term 7 is equals to 9. But we know how to rewrite T7. It will be a plus 6d equals to 9. So we have learned this already. Now I'm going to solve simultaneously for this. So I will put use elimination. It looks a lot easier with elimination or faster. So let me just put the equations underneath each other, and I'm going to choose to subtract them because a minus a will give us 0. 2 minus 6 will be minus 4d, minus 7 minus 9. Okay, let me just quickly get that so that I don't start this over in the calculator. So let's have a minus 7 minus 9 is minus 16, and then d will be positive 4. Now we have the d value. We substitute this information there to get the a value. So that means a plus 2, 4 equals to minus 7. And we solve for the a value, which is 8. Take the 8 to the other side. You get a huge negative number. It's going to be minus 7 minus 8 is minus 15. So we have the d and the a value. Let's come back and substitute it in here. So sum of the first 51 terms will be 51 over 2. The a value is 2 multiplied by minus 15. So negative 15 there. Plus, this is now 50 on the dot. The d value is 4, positive 4. And we just substitute this into our thingy here. So let's just do that. And we're going to have 51 divided by 2. And we just punch out 2 times negative 15 plus 200. That would be 4,000. So 4335. That's the sum of the first 51 terms. Very interesting. Now let's go over to this question. They say evaluate without using a calculator. That means that we have to tell them now what is all of this divided by all of this. And we start to see, well, this is actually an arithmetic series at the top. By the numerator, we have an arithmetic series. By the denominator, we have an arithmetic series. So we can work out the sum of, right? That's what we can work out. But again, I can't work out the sum of if I do not know how many terms I have. So I'm going to use the last values to work out how many terms do we have in those series. So let's do that. So let's say numerator. Okay, save this in the numerator. We say Tn is equals to a plus n minus 1d. Tn is going to be 100. We already learned this technique, guys, that if you want to know how many terms there are and you do have the last term's value, you can use this. And the first term is 4, and we're looking for n. And constant difference would be 4 because you're adding 4 to get 8, you add 4 to get 12. So that would be 4. Right, let's get the n. Let's use our calculator for this. We're going to say 100 minus 4 gives us that, divided by 4 give us that, plus 1, 25. So that will be 25. Let's do the denominator. We have Tn is equals to a plus n minus 1 d, and then we're gonna have 101 equals to 3 plus n minus 1, and our d is going to be okay. So at the bottom over there, we do not have an arithmetic. We do not have an arithmetic sequence going on there. So let's just see what we have. We have 3 plus 10 plus 17 plus so forth. So over there, we have, oh yeah, we do have, we're adding 7 the whole time. Okay, so we have the d value as 7. So let's get n, the n value. So the n value there will be 101, right? Just make sure you see. 101 minus 3 divided by 7 plus 1. That's 15. So we have 15 terms at the bottom. All right, so that is what we have so far. So we know how many terms we have at the top. We know how many terms we have at the bottom. So let's work out their sum offs, and we can just take those values and divide them. That's how we evaluate this. So now let's get the sum of, right? Let's put the formula. I'm going to write the formula here at the top so that you can see it. And I will just substitute into it here. I think that will be very easier. Skip a step. So we say S 25 over 2. 2 times the first term, which is 4, times n is 25 minus 1. And the d value we said is 4. Right? We're going to put that into the calculator together, and we're going to get 25 over 2 multiplied by 8 plus 25 minus 1, and we put a times 4 outside. So I get 1,300. Then we go over here, we say S 15 over 2 multiplied by the first term is 3 plus 15 minus 1. The last term is 1. So I could have used the last term 1, but the d value here is 7. So I should have used the L one. That would have been a lot faster, quicker as well. So let's do that together. Oh, I shouldn't remove it. Okay, but it's fine. Now we have 15 over 2 multiplied by 6 plus 14 plus times 7. We get 780. So now we have 780 over there. So when we evaluate, we have 1300 over 780, and that will give us, or you can even do this, 4 plus 8 plus 12 plus so forth until you add the last term, which is 100, over 3 plus 10 plus 17 plus until you add the last term, which is 101, is equals to 1300 over 780, and that will give us, let's see. All right, so we have over there 3 over 7, 8. So that's 5 over 3 as our final answer. Final answer, 5 over 3. So yeah, let's move over to the next question here and keep it going so that we can finish. And I'm pretty sure we have just 2 more questions and we'll be done. So we have the second term of an arithmetic sequence is this, and the sum of the first 6 terms of this will be that, and they are asking for the first term's value, which is the a, and the common difference, which is d. So we're just gonna write we know that t second t2 is equals to -4, but we can rewrite this as a plus d equals to -4. S, to say the first 6 terms, sum of the first 6, so S6 is equals to 21, and we can rewrite this as, let me try to formulate it. So S6 would be 6 over 2. Well, let me just do it. 6 over 2, because remember I'm substituting into the formula. 2a plus, instead of a 6 I have n, I have a 6 minus 1 d equals to 21, and I'm going to simplify this a little bit more. So I'm substituting into the formula, right? So we're going to have 3 here. So this is 3 times 2 is 6. So we have 6a plus 6 minus 1 is 5. So we have 5d times 3 is going to give us 15d equals to 21. Then we can solve for these. Let's use the elimination method. I like the elimination method. I'm just going to multiply this equation by 6 to form a new equation of 6a plus 6d equals to -24. Then I'm going to write the equations underneath each other. I'll put 6a plus 6d equals to -24, and I'll subtract the equations. This will be a lot easier for us because I get 0 there. 15 minus 6, that will be 9. So that's positive 9d. 21 plus 24. Well, let's just do it here. It will be 5, 4. And now we know our d value is going to be 5 because 45 divided by 9 is 5. So the d value is 5. Let's substitute this back to this first equation because it's simpler. So I have a plus 5 equals to -4. So the a value should be -9. Right, so that's how you work out that. Let's continue here. I hope I didn't need those values. Oh yeah, I did. Let me try to remember. A was -9 and the d value was, my goodness. All right, I think it will come back to me. Anyway, we have to work out term 100. So term 100 is equals to the sum of the first 100 terms minus the sum of the first 99 terms. So the sum of the first 100 terms will be a 100 over 2. We're substituting into the formula, right? 2, and the first term is -9 plus 100 minus 1, and the d value, which I'm forgetting. And then this one, we have 99 over 2, and we have 2, the a value is 9 plus 99 minus 1, and the d value, it should come back to me. I substituted a 5. It was a 5, so it's a 5 here. Okay, there we go. So we put this into the calculator. Sorry, we're gonna put this into the calculator, and we're gonna get our answer here. All right, so I hope you can see what we have. And now let's just bring back the calculator so that we have 50 multiplied by -18 plus 99 times 5. Close brackets. Let's go to 99 over 2 multiplied by -18. Bracket -18, and then we have plus 98 times 5, and that's gonna give us answer of 486. That's how you do this question. Let's do the last question there, guys, and I hope by now you're getting the hang of it. Some questions have unknown values, so you're gonna have to first work out the unknown value so that you can work out the actual sequence or whatnot, and then do your sums. So here to say the first three terms of an arithmetic sequence are given as this. First term is 2x minus 5. Second term, third term. Now let's say determine the value or values of x. So hopefully it's a value of x, so we can have a short sum. So let's do it. So the way we get x, we have to write down the sequence as it is. So we have 2x minus 5, and then we have x plus 5, and then we have 3x, and so forth. Now we need to work out the common difference, right? Remember, that's what you always do when you write down your sequence. So you say this bracket, x plus 5, must subtract that bracket, which is 2x minus 5. And then let's work out the common difference here. So we have 3x subtracting the bracket of x plus 5. Right? So this is the d value, and that is the d value as well. So because they are both the d value, we can set them equal to each other. So now we have a linear equation, and we can just solve for this. So therefore we have x plus 5 minus 2x plus 5. Remember, the negative must multiply in here. Then we have 3x minus x minus 5. So let's solve for this. So now I'm going to have these guys giving us a negative x, negative 3, x plus x. I'm just solving for this question my way. And we're going to have a 10 here going on. And then take that positive 10 becomes negative 15 on this side. So cancel these guys because they're the same. So we have negative 3x is equal to negative 15. So we have positive 5 for your x value. So we have a value of x, which is amazing. Now what you want to do is just come back to the sequence and substitute that 5 there. So let's see. I'm going to substitute that 5 in there. And I'm going to use a calculator. So if I use the calculator, I'm going to have 2 times 5, right? In the first one, where there's a 2x, where there's a x, I put a 5, minus 5. And it's going to give us a value of 5. So my sequence goes 5, and then 5 plus 5 is 10, and this should be 15. All right, so I didn't need that calculator after all. So this is my sequence. I'm going to remove all of this. I remember my sequence was 5, 10, 15. Now they want us to work out Tn, the nth term. So we go ahead, we solve here. We say Tn is equals to a plus n minus 1 d. And then we work out Tn. Where there's an a, we're going to substitute 5 because it's the first term's value. N minus 1, the d value is also 5. So Tn is equals to 5 plus 5n minus 5. So those guys are going to cancel each other out. So we have 5n for Tn. The sum of the first n terms is 180. They want n. So C, we have Sn is equals to, we don't know the last term's value, so we have to use this formula. And then sum of, they told us is 180 equals to, well, we're looking for the n. So n over 2 times 5, because the a value is 5, the first term's value, n minus 1, and d is going to be 5. And we close our brackets, take the 2 to the other side. 180 times 2. 180 times 2, 360. All right. So sometimes the mind is just sleeping. So we have over here 10. So we have 10n. And then, okay, you know what? Let's just leave the n outside and simplify inside. So we have 10 plus 5n minus 5. And we have 360. 10n. Actually, I don't even want to have 10n. I want to have 10 minus 5 is just 5. So this will be 5n. These guys give us the 5n plus 5n squared. Now I can divide by 5 all throughout here. 360 divided by 5. Let's do that. 360 divided by 5 will be 72. So we have 72 equals to, well, n squared plus n. And we can just try to factorize this one as well. So we have, let's have n squared plus n minus 72. You can use your quadratic formula from here. Yeah. So let me find the factors here to cross multiply them. I have an n and an n. Factors of 72 that will subtract and give us 1 will be 8 and 9. All right, so we have our factors. So we have open up two brackets. I have a n, I have a n. I would have a plus and a minus, opposite signs. The biggest one, 9, and this is a 8. So we have n equals to minus 9, or n equals to positive 8. So not applicable for this. So we say therefore n is equals to 8. So if you have the sum of being 108, that means that you added 8 terms. That's it for this video, guys. I hope you did enjoy it, and we will see you in the next one.